what is the domain of r of x equals x plus 3? Well, again, we have to ask ourselves the following question. What is the real allowed? I know we're allowed real numbers, but is there any problem here that we can see? And I'm going to break this out into different parts. I'm going to look at the numerator. So I'm looking at the numerator. And what is the domain of the numerator? Just the numerator alone. So it looks like, as far as the numerator is concerned, I don't see any problems. The numerator domain is all real numbers. I mean, all I'm doing, I'm not even doing an operation. I'm just entering a real number. So that's not a problem. What about the denominator domain? Is there any problems there? And again, what am I doing? I'm just adding two numbers. Big deal. So again, we already established you're just adding two real numbers because the real numbers, the denominator is also all real numbers. Great. Unfortunately, there's one more operation. There's division. Okay. And with division comes an issue. What's 3 divided by 0? The answer is, well, there is no answer. This is undefined. It's nothing. It doesn't produce anything. So 3 divided by 0 is off limits. It's undefined. It doesn't produce anything. However, if I do 0 divided by 3, the answer is 0. So 0 divided by any other number is undefined. And also, just in case this crossed your mind, what if I have like 0 divided by 0? This is also undefined. This is definitely not equal to 1. So I guess this is what I'm after. I'm not, 0 over 0 is not a 1. Okay, I know that 3 over 3 is 1. Basically, real number divided by real number equals 1, except this being the same real number, except for 0. As a matter of fact, this is a different type of violation. 0 over 0 is undetermined. What does that mean? Don't worry about it. It's like a worst case of undefined. This is when we say, hey, we have no idea what this is. This is a different kind of violation altogether. So no good. Okay, so now that brings us to the following scenario. Wait a minute, can we have a situation where here that we have this, a real number on top, but we're dividing by 0? And the answer is, yeah, let's figure this out. So what we need to figure out now is what real number I enter here, and it produces a 0 for the denominator. So we're going to have to do this. What makes the denominator 0? What input here, just sitting right there, will cause the denominator to 0? So we solve. And we get -3. So it looks like if I enter -3 into this thing, what happens? Well, what I get is -3 plus 3, and I get the violation. -3 divided by 0, which is not a real number result. Everything else is fine. So if I were to draw like a nice little number line, we have 0 here, that's great. And we have a problem right at there. With a positive negative, but no good. 3 is the only exclusion. The domain is -infinity to -3. Exclude that, union with -3 to infinity. There's my domain. So for this type of equation, where we're dividing two equations by the process of finding the domain, is as follows. Determine the domain of the equation in the numerator. Determine the domain of the equation in the denominator. And also find the value that produces a zero. And exclude that number from the domain. Okay, so we have to do things, find the domain of the denominator, but also figure out what causes the output to be a zero, what produces a zero, so it's an output. Okay, so that makes it kind of interesting, right? Because we have to kind of take care of a few things here. So the domain of the entire function are the values that are common to both numerator and denominator, the domains. What is it? Well, the intersection of both domains. Of both domains. Both domains mean the numerator and the denominator.